All right, some rational expressions are complex fractions. So you can see this, okay, which you have seen a complex fraction before. We basically are going to look to invert and multiply it here. So for example, if you had 1/2, it's always great when that happens. If you had 1/2 divided by 1/4, remember what you did with a fraction like that? You would do what to the second one? The denominator. Invert and multiply, right? So 1/2 divided by 1/4, you would invert. This becomes 4/1. That becomes 4/2, and you simplify to 2, right? That's all we're gonna do. We're just gonna add some letters in there. Now, they can be a little bit different, a little bit tricky, especially ones like that where we'd have to add those together first, okay? But some of them would be very simple like this one. This would be x plus 2 times x over 3. That'd be pretty simple. X times x, so it'd be x squared plus 2x over 3, okay? So some of them are pretty simple. But the key here is you're gonna be inverting and multiplying. Now, again, this one, we'd have to add first before we could do that. Let's take a shot at a couple of these. What do you think? Do we need to do anything ahead of time? Or is this just ready to invert and multiply? Well, it's ready to just invert and multiply. So it becomes pretty simple. Remember, it is simplify. So if we could cancel, we would. So what's going to become on top now is x plus 5, okay? And what's going to be down here would be x minus 3. So I've inverted, so this is gone. Assume all expressions are defined. That takes that off our plate, right? We don't have to worry about where the denominator goes to 0. So really we're down to FOILing. X times x will give me x squared. Now that's going to give me plus 5, right? And then a plus 2. I'm going to do the two middle terms. Is that okay with everybody? So I have plus 5 and plus 2 would give me plus 7. And then I have 2 times 5, which would be 10. So I FOILed that guy out. We're going to do the same with the second one. X times x will give me x squared. I'm going to have a minus 3 and a minus 1, which gives me negative 4x for my middle term. I'm just combining those in our head. Then negative 1 times negative 3 will give me positive 3. Assume all expressions are defined. Don't need to worry about our denominator going to 0. Are we good to go? Are we solid? Makes sense, everyone. It's pretty simple, invert and multiply, right? Okay, now here's when it's not simple. Watch. What's the difference?
You have to add up top.
We're going to have to add the top. See what you can do. We just did this. 3 over x plus x over 2. What's my common denominator going to be? 2x. Figure out what I'm missing on the left, multiply top and bottom by it. Figure out what I'm missing on the right, multiply top and bottom by it. Come on, look. Engage yourself a little. this up for you. Let's see. Hoping that you're understanding that we're gonna multiply both top and bottom by 2, right? And here we're gonna multiply both top and bottom by x. Does that hopefully make sense to you? Okay, I'm gonna put it in standard form, so I'm gonna put the x squared first. Plus what? 6. So that's a simple rational expression added to another rational expression. Does everybody feel okay? Now, what does that allow me to do? That allows me to be ready now to say x squared plus 6 over 2x divided by x minus 1 over x. Now I'm ready to do what with that denominator? Invert it and multiply. Okay, so let's get some brackets up here. This is going to be x over x minus 1. Okay? Now, there's some stuff here that we can do. Simplify, assume all expressions are defined. Okay? We could multiply and get everything done, but since it is multiplication, what's always on the table? Yes, canceling is always on the table. Okay? Does anybody see anything we can cancel? Yeah, the x's can cancel. Okay? So now what do I have? X squared plus 6 over, I'll distribute this 2. We'll make it 2x minus 2 and we're done. Assume all expressions are defined, don't need to worry about that. But remember, when we are multiplying, if we have a single x, which we did there, we could cancel. If we have binomials that are the same, we could cancel, but we don't. This doesn't factor. This does not factor. X squared plus 6 does not factor. There's no binomials to be canceled like we've done in the past. Yes?
Why did we cancel that x right there?
Where?
The x minus 1, the x.
Oh, because that's a binomial. Has nothing to do with that other one.
Alright.
The only way I could cancel that is if I had another x minus 1 up here, then I could cancel those, but that's not the case, okay? Roll with it. Do I need to add anything together first? No, this one's a simple one, but you can do some canceling here, see what you can do. Always be in the hunt for those perfect square binomial, which the bottom, the denominator of the top is a perfect square binomial. It does factor, which will allow us to do some wonderful 3 days in here. Favorite phrases.
Mm-hmm.
Anybody know when the end of the 9 weeks is?
Next Friday.
As you're right. Make sure you're taking care of business. That's how that guy ends up looking. What can we cancel? A lot of stuff, can't we?
Yeah.
Assume that all the expressions are defined. What's this thing end up being? 1 over x. Make sure you have that 1. Why? Because everything on top ended up getting eliminated, right, or canceled. We got that left. Did you question?
What happened to the x squared minus 1? Why'd you filter that out like
But,
that?
well, because it factored. X squared minus 1 factored the difference of perfect squares. X minus 1 and x plus 1. And so that allowed me to do some canceling. That's why I factored. Assume all expressions are defined, so we're good there. Questions, anyone? Are you sure? Last one. Might be able to do some canceling here too, or some simplifying to see what you can do.
Did you get like 60?
I'm gonna take that 3 out, bring that 3 out front. Always looking for a GCF. Why'd I bring that 3 out? Because now I can do what I'm ready to do some canceling here if I can. Assume that all expressions are defined, don't need to worry about that. So these binomials can go. I'm down to what? There are no variables in it anymore. I'm down to numbers. Okay, I'm down to numbers. What do my numbers give me? 20 over, what's the whole thing simplified to?
10.
It does, it simplifies to 10. What does that mean? Think about the meaning here. I know this might be beyond what some of us want to do. Does it ever matter what I put in for x? What if I put 1,000 for x? What's the outcome going to be? And what if I put 5 in for x? What's the outcome going to be? 10. It does not matter what I put in. The outcome for x is always going to be 10. Questions here? Just knock a few out. Easily get those done before you leave.